Hello, dear students. Welcome to the this eighth lecture of Icgt. In the last lecture, we learnt about the open cycle and closed cycle gas turbines, the Brayton cycle, and all these things. Now, in this lecture, we'll talk about the advantages and disadvantages of different cycles. Now, let me compare the open cycle and closed cycle gas turbine. In open cycle gas turbine, there is warm up time. Once the turbine is brought to the rated speed by the starting motor and the fuel is ignited, the gas turbine will be accelerated from cold start to full load without warm up time. You understand this? In case of open cycle gas turbine, each time the gas passes out, the same gas is not being coming back, not being recirculated. So a new gas, a fresh gas enters inside the turbine. So there is some warm up time. It is to be heated, it is to be compressed, then hot air, at high temperature, the gas at high temperature and high pressure should enter into the cycle, and the cycle should rotate. That means the turbine should rotate. So it requires a warm up time, which is somewhat difficult in case of gas turbine, because every time you start from zero, the fresh air is heated and then it comes back. In case of closed cycle, it doesn't start from zero. In closed cycle, as I have said, the same gas is being recirculated again and again. So gas, to some extent, even after cooling by the cooling turbine, remains hot. Not cooling tower, even after cooling by the cooling tower, remains hot, and that hot gas comes and recirculated, and the warm up time is less. In case of open cycle gas turbine, the warm up time is more required. Required more. Low weight inside. The weight in kg per kilowatt developed is less. Kg per kilowatt. That means if it produces 100 kilowatt, say a gas turbine plant, and we compare between a 100 kilowatt open cycle plant and a 100 kilowatt closed cycle plant, the weight of the open cycle plant is less. Weight in kg per kilowatt developed is less. Because in case of open cycle, you don't have the weight of the cooling heat exchanger. You understand the cooling heat exchanger? I'll show you. This is this heat exchanger at the bottom. This heat exchanger at the bottom. This is the cooling heat exchanger where heat is rejected. That is there in closed cycle. It is not there in open cycle. So that weight totally goes. Along with that, the installation cost of also goes. So the installation cost becomes somewhat less. Open cycle plants occupy comparatively little space. Now, I have to further discuss the low weight side and size. In case of a low weight turbine plant, it's easier. If the weight is less, it's easier to transport the turbine plant. It's easier for the flexibility of the turbine plant to remove from one location to another location. It's easier to load it in a truck and to download from the truck and all these things. So low weight helps in all these things of flexibility in operation and movement of the gas turbine. Open cycle plants occupy comparatively little space. In case of open cycle plant, space occupied is comparatively less. Why comparatively less? Because you can see In case of open cycle, there is this heat exchanger. I was talking about this heat exchanger is there in case of open cycle gas turbine. In case of closed cycle gas turbine, I mean this heat exchanger is there. In case of open cycle gas turbine, this heat exchanger is not there. You can see this heat exchanger is not there. There is no heat exchanger here. There is no heat exchanger here. So, as a result of that, the open cycle plants occupy comparatively little space. A total heat exchanger is out of question in case of open cycle gas turbine. A heat exchanger is a big body where there is more surface area required. Why surface area, you know? Because you have the formula Q is equal to UA delta T. Overall heat transfer is equal to overall heat transfer coefficient U into surface area A into temperature difference delta T. The more the surface area A increases, the more is the heat transfer. So, to increase the surface area of in case of a heat exchanger, the bigger the size of the heat exchanger, better is the heat transfer of the heat exchanger. So, this is a preliminary part of that. That is why generally a big area is being taken by a heat exchanger. In case of open cycle gas turbine, one heat exchanger where the heat rejection takes place is not at all required. We are making the gas to go out in the atmosphere. So, there is less occupation of space. So, for that reason, we have comparatively little space. Open cycle gas turbine, number 4 point. Open cycle gas turbine power plant, except those having an intercooler, does not require cooling water. Now, intercooler. Intercooler we will talk in future classes. It is an efficiency increasing device. It increases the efficiency of the turbine. So, I am not going to talk about intercooler directly about here. But it does not require cooling water. Try to understand. What is cooling water? Where cooling water is required? Here in the heat exchanger. This heat exchanger makes a heat transfer Q out. I told you in the last class, the cooling water comes to heat exchanger, takes away heat from the hot gas, itself becomes hot, and that hot water which takes heat from the gas, the water becomes heated, that hot water is being taken to cooling tower. In the cooling tower it is cooled, and that cold water is again being recirculated, and it happens continuously through the cycle. So, as it happens in case of heat exchanger, the proper cooling and the heat rejection takes place. So, in case of closed cycle, you require a separate cooling water system. Means what? You need a cooling tower. Whenever you buy a cooling tower, extra cost is there. You need water. Enough of water should be there because through the cooling tower, a lot of water gets lost into the atmosphere. And you have to make up that water from time to time every day. You have to clean the water continuously because there is fouling because of outside leaves, dirts, dusts, all these things coming in the accumulated in the cooling tower. So there are so many maintenance disadvantages coming with that. Since in case of a open cycle gas turbine, you don't have this cooling water. As a result of that, since you don't have a cooling water in case of this, it does not require cooling water. As a result of that, does not require cooling water. And as a result of that, the cooling is high in this case. So, in case of open cycle gas turbine, you don't require cooling water and a lot of hassles are removed. installation cost is removed, cooling water hassles are removed, filtering of water hassles are removed, and so many advantages are there. The part load efficiency of the open cycle plant decreases rapidly as the considerable percentage of power developed by turbine is used to drive the compressor. Try to understand what is part load efficiency. You have selected a gas turbine plant of 100 megawatt capacity, say. Now, throughout, this generally supplies as a supplementary power to the power plant. Now, the power plant requirement increases or decreases depending on what load is coming for the power. Say, for example, on 5th of April, there was a total shutdown of power at 9 pm as per call by our Prime Minister. Now, what happens? As a result of that, the load decreases tremendously in the power plant. And the power plant may not run. Instead of that, a gas turbine may be able to take the power. And again, that gas turbine power depends on what power load is coming on that. That power load may be sufficiently less. If the power load is sufficiently less, so at the part load efficiency of the power plant, the part load means what? What is to run at 100 megawatt power is running at 60 megawatt power, 50 megawatt power, 40 megawatt power. That is part load. And whenever a plant runs in a part load, it loses a lot of efficiency. Say at full load, that is at 100 megawatt power plant, if gives an efficiency of 50% or 60%, at part load it may give hardly an efficiency of 20% or 30%. That is always there. That is actually in case of both open cycle and closed cycle, both cases it is there. Part load efficiency of any system is generally less as compared to the full load efficiency. And further to that, a large amount of power goes in running the compressor. You come to the cycle. You see, this turbine shaft is connected to compressor shaft. Let me come to the open cycle. In the open cycle, the turbine shaft is rotating the compressor shaft. So when the turbine is running at part load, even then it is taking almost a full load at the compressor. So the part load efficiency, lot of the part load efficiency depends on what? What is the output by input in the turbine? A lot of the output is being eaten up by the compressor. So the power output decreases tremendously. Number 6 point. The open cycle gas turbine plant has high air rate compared to other cycles. Therefore, it results in increased loss of heat in exhaust gases. That means, in case of a open cycle gas turbine, a fresh air is coming, getting heated up, and being lost every time as exhaust gases. So a lot of heat goes for nothing. Loss of heat goes for nothing. What happens? Try to understand the difference between a open and closed cycle. In case of a closed cycle, the gas rotates the turbine and its pressure drops, temperature drops. Now this, even after the temperature drop, it remains at sufficiently hot condition, which is cooled by the cooling water from the cooling tower, and then it is recirculated through the system. So loss is less. We are using the gas again, whatever heat is there in the gas can be, helps in decreasing the reheating of the gas in the combustion chamber, because it is already heated up to some extent. So it decreases the heat required in the combustion chamber. But in case of open cycle gas turbine, the whole gas goes out with the total heat loss. A fresh gas is to be taken, and again it is to be heated from beginning to the temperature needed to run the gas turbine. So you understand the difference. In case of closed cycle gas turbine, the gas is already heated and we are reheating the gas, so heat required is less. In case of open cycle gas turbine, we are heating the fresh gas, so heat required is more. So that gives more loss of heat. So efficiency decreases in case of open cycle gas turbine. That way. Now we are coming to closed cycle gas turbine. In closed cycle gas turbine, the machine can be smaller and cheaper than the machine used to develop the same power using open cycle plant. Now, it's somewhat a relative matter. Smaller and cheaper in the fact is the fact that in the operating cost it is cheaper. In the installation cost it is not cheap. Because why it is not cheap in installation cost? Because in case of an open cycle plant, for cooling the gas, you need a cooling tower, separate cooling tower to be bought. A fresh water system is to be there, and for that a water pump is to be there. That cost is there. A filtration cost of water is there. Continuous maintenance of the cooling tower and water is there. All these coming together actually increases the installation cost. But if you see in the longer run, we are using the same gas again and again, recirculating. So the burnt gases are not left out in the environment. We are reusing the burnt gases. Burnt gases means the gases which are used in the turbine. We are reusing it, which is already heated to some extent. So that helps in resolving the matter. So machine can be smaller and cheaper in the sense that the operating cost becomes less in case of closed cycle gas turbine. Try to understand why operating cost is less. Operating cost is less because the same gas is recirculated again and again. We are not throwing it away, what we are doing in open cycle gas turbine. That is number one point. Also, the machine can be smaller other than the heat exchanger that you are using for rejecting heat. Other than that, if you don't take that into consideration, the other parts are comparatively smaller because one is combustion chamber is smaller. Why combustion chamber is smaller? Because the gas we are recirculating is already heated up to some extent. So heat to be added is less in combustion chamber. So the surface area required in combustion chamber for heat transfer is less. So combustion chamber is smaller inside. Also, the gas remains to some extent at higher pressure even after losing pressure in the turbine, which we are recirculating. So the load on the compressor is also less. So compressor can be of smaller size. So the machine can be that way smaller and cheaper as far as the installation cost, cheaper as far as the operating cost is concerned. Installation cost will be high because you are adding cooling tower, you are adding water pump, you are adding filters, you are adding the maintenance system for that. You need water, so the place should have sufficient water also. Like in condition like Chennai, where water is a scarcity, this is a big problem. Having a closed cycle gas turbine, how do you run it? How do you get so much water for cooling tower? Where water, the drinking water is a big problem. Where do you get enough water for industry use? This is the question. Number 2 point. The closed cycle avoids erosion of turbine blades due to the contaminated gases and fouling of compressor blades due to dust. Therefore, it is practically free from deterioration of efficiency in service. The closed cycle avoids the erosion of turbine blades. What is that erosion of turbine blades? Because of the constant fresh air being taken in open cycle. a lot of dust particles, impurities, etc. come along with air, even after filtration. The small dust particles will come even after filtration. Because you are not going to put a very high level of filter inside, because the more high level filter you put, more is the suction cost in the compressor. Try to understand. Filter provides a resistance to air suction to compressor. And more is the air suction required, more is the power required in the compressor. And where the power comes from? Power comes from turbine. So it eats up more power from the turbine, which is to be supplied to the power plant. So we don't use a very high level of filter there, it's a very low level of filter. In that, a lot of dust particles goes inside the turbine blades, and turbine blades get eroded due to the contaminated gases. And fouling of compressor blades due to dust. But in case of closed cycle gas turbine, what you are doing, there is no connection of the gas inside with the outside environment. So the same gas being recirculated again and again, so it is dust free. It is impurity free. Because being dust free, impurity free, vapor free, water vapor free, and all these things, it reduces the erosion due to rusting or other chances of the turbine blade. Erosion is reduced drastically in case of closed cycle gas turbine. This is a very, very big advantage. Because when erosion of turbine blades happen, you have to make a regular maintenance of the turbine blade, which is costly affair. Number one. Number two, your downtime increases. Down with the shutdown time of the machine because of that. Number three, changing of the turbine blades when required. Lots of cost. Each blade costs very high because each blade is having a particular aerofoil design. All these things adds to the cost. Number three, the need for filtration of the incoming air, which is a severe problem in open cycle plant, is completely eliminated. I was just talking about the filtration. Filtration of the incoming air is a big problem. Filtration of the incoming air is a big problem. The more is the level of filtration, higher is the suction force required in compressor. Higher the suction force required in compressor, higher is the power required in running the compressor shaft. That means higher is the input of the compressor and the output is less. That is, the efficiency of the compressor goes down. And higher input of compressor means higher loss of power from the turbine, because turbine shaft rotates the compressor. Higher loss in the turbine shaft means less power going to the power plant, which is my main intention. So, the need for filtration is a balance in case of open cycle gas turbine. You have to use the filter. The filter will get choked after a few days. It is to be taken out. It is to be filtered. It is to be maintained. There should be maintenance schedule of the filter. After too much choking is there, the filter is to be replaced, so the maintenance cost is there. All these headaches are there in open cycle gas turbine. These headaches are not at all there in closed cycle gas turbine. Because in closed cycle gas turbine, you are recycling the same gas again and again. So there is no scope of special filtration for that. The gas itself is impurity free, dust free, water vapor free. Filtration is not required. The maintenance cost is low and reliability is high due to longer useful life. Why life is longer in this case? I told you, as you in open cycle gas turbine, you are always taking a fresh gas. The gas may be with impurities, dust, vapor, so many things. They come to the turbine, erode the turbine, you go for maintenance of the turbine. You filter the system, you go for maintenance of the filter. So the maintenance cost in this way it is higher. In case of closed cycle gas turbine, also you have maintenance. You have maintenance because of the cooling tower you have provided that requires water. So you need water also. You need filtration system also, and accordingly the system is to be designed. Now again, it depends on the availability of the resources. As an engineer, you have to decide if the plant is coming out in Chennai. It's a big problem because water is a big problem in Chennai. So in a closed cycle gas turbine may be difficult in Chennai because you have to supply lots of water for cooling tower. You have to supply water, lots of water for cooling the heat exchanger where the heat is being rejected continuously. That involves a lot of cost. Who will pay the cost? The client is to pay the cost. The player who is making the turbine work or who is giving guarantee to produce just that particular amount of power in the power plant, he is bearing the cost. Effect will come in the billing of the electricity. See, all these things are interconnected. You cannot take something out of that. I think you can understand what I am doing. The maintenance cost is a thing which is a comparable thing. In case of a Chennai, the maintenance cost of water may become higher in case of closed cycle gas turbine as compared to an open cycle gas turbine because water is very costly there. But in case of Kolkata, where water is abundantly available, there is a river full of water, or eastern part of the country is full of water. So there you get lots of water free. In that case, the closed cycle gas turbine is better. In any case, water is not costly. So it depends on the place, the availability of resources, and the application where you are going to use it. That is the engineering decision you have to take, basically. That's where your brain is needed. You have to decide as an engineer what is to be used where. Number 5 point, the system is dependent on external means as considerable quantity of cooling water is required in the pre-cooler. That means the same thing. External means cooling water required in the pre-cooler or heat exchanger, wherever you have a cooling water requirement, you need to have a lot of water for that. And for that, a separate system is to work. I already explained how a cooling tower is to be maintained, how water is to be maintained, how water pump is to be maintained. So that acquires a separate system working on that. That's what the point number 5. Point number 6, the response to load variations is poor compared to open cycle plant. That's the part load. I am talking about part load. I again explained the open cycle, I am explaining here also. The part load is always a big problem in industry. A 100 megawatt power plant, when it runs at 60 megawatt because of the falling of load, the efficiency does not decrease in the same manner it should decrease. The efficiency remains always less in part load as compared to the full load. Say at 100 megawatt capacity, if gives an efficiency of around say 70%. At 60 megawatt, it may give an efficiency of around 40%. Are you understanding what I am telling? 100 megawatt means it's full capacity it's running. It's a full capacity plant. The same plant when runs at 60 megawatt, the load falls now. You understand load falling? Say power plant in Delhi, what is running in winter, the load requirement is much less as compared to when it is running in summer, because the air conditioning loads are very high in summer. Because of the air conditioning power loads, lot of electricity is required. So you design the power plant for summer time. Now when you move the power plant for the winter time, the load requirement falls. That time it is running at part load. 100 megawatt power plant runs at a part load of 60 or 70 megawatt. And that time the efficiency goes down. That means as a result of what happens ultimately? You are the payer of the electricity bill. what you are paying in summer as compared to that in winter, it does not decrease to the extent it should decrease to, because the efficiency is lesser in part load as compared to efficiency less is higher in full load. It may take some time to understand the connotation I am telling about. Just think about that and you will get a clear idea about that. Okay, students, this is up with the next class. I think it is clear what I am telling you. In case of any doubt, you can ask me any question. I will be very happy to answer you. We are talking about gas turbine, the open cycle, the closed cycle, their differences, their advantages and disadvantages, all these things. Thank you for attending the class. Bye.